Clicking on the camera is common, but let me discuss a unique feature that when you press a button to click any pic, it auto starts a flashlight which remains on till the camera is setting a focus on the object. It is very important because it enables us to take picture in the evening, night or at the dim natural lighting with the better quality. I am sure you want to know how it actually works. So let's have a look. The complete solution can be segmented in a multiple ways. So to start with, we take a power supply and then in the circuit there is a trigger. When we triggered it, discharging unit get activated and the signal will be generated, and on the output we get the flashlight that is on for few seconds. As we have understood the process in block diagram, here we have components connected in a specific pattern to solve the purpose. We have resistances, capacitor, switch, battery, transistors, LEDs which represent flashlight. So to understand this circuit, let's start with the capacitor. Capacitor has the capacity to charge and discharge itself. Here we can take a case 1 when the switch is not pressed, and if switch is not pressed, this line is not connected, so no current will flow on this line, and in this case capacitor gets charged through the resistance and VCC. Once the capacitor is charged, it generates high voltage on this line, and so the base of this transistor have the high voltage, and transistor work if the base has greater than threshold voltage, then transistor get activated, and so the current will start flow from base to emitter and collector to emitter. If the current is flowing on this line, we get voltage on collector same as emitter. So here we get 0 volt, and this 0 volt or low voltage will transfer to the base of this transistor, and so the transistor remains off. Since the transistor is off, no current will flow on the emitter, and so the flashlights or LED remains off. Now the case 2, when we click on camera or the switch is pressed, this line gets connected, and so the capacitor gets discharged itself through this line, and here we get 0 volt. Once we get 0 volt, this transistor get deactivated, and so this collector point is independent now with the emitter, and here we start getting higher voltage through this path. Once we get higher voltage, it will activate the transistor, and finally we get the flashlights on. Now let's discuss what will be the timing till then this flashlight will remain on. So as the switch is continue pressed, so here we get the accumulation of negative charges, and on contrary this side we get the positive charge again, and that will activate this transistor because the voltage gets high now, and once this transistor gets on, again we start getting 0 volt here, which deactivates the transistor. So after a certain time this LEDs will get off. The timing will depend on the value of this capacitor. The larger is the capacitor, it will take more time to get charged and generate enough voltage to activate the transistor Q2. Again, we have connected the 9 volt battery as a power supply to this circuit, and we have resistances of 1 kilo ohm to limit the current on this line. Here, in this way the circuit works. Now let's implement it on the breadboard to check the functionality. As we have seen in the circuit diagram, here I am going to connect components on the breadboard. So here is the battery cap, of which positive and negative pins are now connected, and then here is the 470 ohm resistance, of which one leg is to be connected on VCC and the second leg is now connected here. Now we have to connect a capacitor. Positive leg of capacitor is with the resistance and negative leg is on the breadboard. So the capacitor is connected. Now we have to connect this 22 kilo ohm resistance with VCC. Here is the VCC given to 22 kilo ohm resistance, and the second one is connected to the capacitor negative terminal. Now this point is further connected to a transistor BC547 NPN transistor. Here I am placing it on the breadboard. It is connected now. On the base, we will connect through a jumper wire, and here it is connected. This is 2.2 kilo ohm resistance. One end is to be connected with the collector of transistor and second end is with the VCC. Now the emitter is connected with the ground, so I am taking a wire again, got connected. So again BC547, and I am connecting it to breadboard now. For further connection, I am taking another jumper wire. One end of it is connected with the collector of first, and here the second end is connected with the base. Now we have to connect the collector of second transistor with VCC through 1 kilo ohm resistance. So I am taking it. Here the collector and VCC are connected through 1 kilo ohm. Next step is to connect emitter with the flashlight or LED that we are using. So one LED is connected, positive pin of the LED is with the emitter. Again I am taking second LED for better lightning. Again the positive end is connected with the emitter, and second end is connected on the ground through a jumper wire. So I am taking this jumper wire, and here I have given the connection. So finally it is connected now. Switch we have to connect on one end is on the capacitor and second end is on the ground. So here it is connected. Everything is done now. We have to connect the power supply and check whether it is working or not. Here I have connected the supply, and let me push it. Yeah, you can see when I click this push button, which represents the camera button when we are going to capture a picture, flashlight automatically gets on, and definitely after a certain time it will get off, like here. So everything is working fine. More than that, there is one more feature. When I press it, suppose, and now I drop the plan of clicking the photo, as soon as I leave this button, flashlight automatically gets off. So it's a perfect automatic circuit which can be implemented in any camera, which makes it more advanced than ever. Stay tuned with our practical learning resource platform. Please like, subscribe and share. Thank you.